June paper 41. Let's take a look at question number 1. The managers of a hardware store is interested in whether there is a difference in the amount spent per customer on weekdays in X, and then compare with the weekends in Y. Random sample of 120 customers on the weekdays and 80 customers on the weekends are taken, and the amount spent by each customer is recorded by the following result over here. So the X is representing the amount money spent in weekdays, and Y is represent the amount of money spent in weekends. Test at 1% significant level whether there is a difference in the mean of amount spent per customer on weekdays compared to weekends. You should not assume that the population variance of the amount spent on weekdays and weekends are equal. Okay, so what we can do over here is we need to do the hypothesis test. First of all, we need to find the mean of X and the mean of Y. So the mean of X is 10470 divided by the 120. And the mean of Y is 6560 divided by 80. So just press the calculator, you get this one as 87.25. This one is the 82. Then we want to find the unbiased estimations of the population variance of X. It will be 1 over the 119 multiplied by 12283. So you will get 103.218. This one, unbiased estimations of the populations of Y, it will be 1 over 79 of 13520. So again, press a calculator, you will get 171.139. So we need to combine these two together as one variance. So we have a combined variance. I use a symbol of S square. It will be the SX square divided by the NX plus the SY square divided by the NY. And press the calculator, you will get 2.99939. I give 5 decimal places to be safe, so that we can get our answer more accurate. Okay, so these are the information that we need to get ready for doing the hypothesis test. Now we can do the hypothesis test. The null hypothesis is that the population mean, that the mu X is equal to the mu Y versus the population's mean. The mu X is not equal to the mu Y because they mentioned there is a difference. Okay, so not equal to the mu Y. So this is a two-tailed test. Okay, so now we can find the critical value. Our alpha is 0.01. So since it's two-tailed, we need to divide by 2. You'll get 0.005. So your critical value from the formula booklet, it will be Z of 0.995. So from the formula booklet, you will get this one as a plus minus of 2.576. This is the critical value. And now we want to find the test statistics. Test statistics, just a formula. So it will be the Z is equals to the bar X minus a bar Y. Bar X minus a bar Y minus the mu X minus the mu Y divided by the square root of S square. It will be 87.5 minus 82. So to save space, I think I will straight away write the value inside here. So just straight away write 87.25 minus the 82 minus a 0 is divided by square root of 2.99939. press a calculator, then you can get the answer as 3.03. We just need to leave our answer in 3 significant figure will do. Now you compare the test statistics. You compare to the critical value. Okay, so you can see that this is actually greater than. That means the Z is actually greater than the Z 0.995. So your test statistics is greater than the critical value. Over here means you reject H now. Okay, so conclusion. So for conclusion, we will write them in the context form. So that means we will need to write that there is sufficient evidence to suggest that there is a difference in the mean amount spent on weekdays and weekend. Spent on weekdays compared to weekends. Okay, done. This will be the answer for the question number 1. Okay, so now we move on to the question number 2. We have a diagram over here shows a continuous random variable x has the PDF. Okay, given by the following piecewise functions over here. A, B, and C are constant. We want to show that the A is equal to 2 over 3, and after that find the values of the B and C. So what you need to do that we know that the area over here, it will be the 1. Total area will be a 1. Okay. So first of all, what you need to know that the integrate from the 0 to 5 fx dx is equal to 1. Okay, or you can say that the total area is equal to 1. Total area, this is a trapezium. So trapezium is a half multiplied by 8 plus 5 multiplied by A is equal to 1. Therefore, your A is 2 over 13 shown. Okay, so this is how you show that A is 2 over 13. Then we want to find the value B. So to find the value B, what you need to do is that we need to put the value F5. Okay, that means if you already know that this is a 2 over 13, if you put F5, it will get 2 over 13. And if you put F8, you will get a 0. Okay, so F5, you will get 2 over 13. And then F8, you will get 0. So you will have B minus the 5C is equal to 2 over 13. I call this one equation 1. And the B minus the XC is equal to 0, which is the B is equal to the XC. That is the equation number 2. Then 2 into 1. So you will have XC minus the 5C is equal to 2 over 13. And then your C is equals to the 2 over 39. Then from the equation 2, you have a B is equals to the 16 over 39. Done. We have found the value of B and C. That is the answer for number 2A. Now we move on to the 2B. Find the mean of X. So to find the mean of X is you need to integrate from 0 to 5 X fx. So we need to split them into 2 parts. The first part is a 0 to 5. Oops, 0 to 8, not 0 to 5. My apologies. This one also is a 0 to 8. not 0 to 5. I make a mistake here. So sorry. Okay, now let's continue over here. This is a 8. So this is also a 8. But we split them into 2. The first sections over here is 2 over 13x. The second sections over here is a 5 to 8. Then you have a b. Just now the b is a 16 over 39 multiplied by x minus the c is a 2 over 39 multiplied by x. This is what you have. So you just have x squared over 13 from 0 to 5 plus the 8 over 39 x squared minus the 2 over the 117 x cubed from 5 to 8. Just replace the value inside, you will get the 25 over 13 minus a 0. Plus the 512 over 39 minus the 1024 divided by 117 minus the 200 over 39 minus the 250 divided by 117. So just direct press everything with calculator, then you will get the mean as a 43 over 13. That's all. This is the answer for the question number 2B. Okay, now we move on. We have a 2C, find the median. So to find the median, okay, actually the median, we need to know that the median will give you the area half over here, half over here. This is the median. So we need to know whether this first part of the area, is it more than half or is it less than half? Okay, so right here we know that this is a 5. This is a 2 over 13. So 5 times 2 over 13 is actually 10 of 13 is actually more than half already. So the median must be less than 5. Okay, so over here, what you need to do is just to calculate. Okay, maybe we can just explain. If you from the 0 to 5 of 2 over 13 dx, you will get this one as a 10 over 13 is more than half. Okay, so that means the median is less than 5. Okay, so what you need to do is you integrate 0 to m, 2 over 13 dx, so that you can get a half. That means you will get 2m over 13 is equal to half. So your m is equal to the 13 over 4. That is the answer. That is your median for the question number 2C. And moving on now, we want to find the CDF of the y. So what you need to do now is we need to find the CDF of the x first. So to find the CDF of the x, we have a f1, which is integrate the 0 to x for 2 over 13. So you get 2 over 13x. Okay, then the f2 is to integrate 0 to 5. And then 5 to x. The b, just now the b was 16 over 39. And the c was a 2 over 39x. So this one is a 10 over 13 plus the 16 over 39x minus the x squared over 39 from 5 until x. So we just press the calculator. We can get 16 over 39x minus the x squared over 39 minus the 80 over 39 minus the 25 over 39. So just join everything together. At the end, you get negative 25 over 39 plus the 16 over 39x minus the x squared over 39. That means your CDF for the f, for the x is given as a 0. and then 2 over 13x, negative 25 over 39 plus 16 over 39x minus the x squared over 39. This one is for x less than 0. This one is for x between 0 to 5 inclusive. This one is greater than x less than equal to 8. This one is for the x greater than 8. This is the CDF for x. Now we need to find the CDF for the y. Okay, so it's a GY is equal to the BY less than equal to y. This will be the BX squared less than equal to y. It will be the BX less than equal to the square root of y. That means I'm going to replace all the x over here to become square root y. So this is actually the same as the f square root y. Okay. By the way, the meaning for this one is this. Okay, so you need to make it become square root y. You have a 0, 2 over 13 square root y, negative 25 over 39, plus the 16 over 39 square root of y, minus the y over the 39. This is the 1. This is the square root of y less than 0. This is the square root of y between 0 to 5. This is the square root of y between 5 and 8. And this is the square root of y greater than 8. Okay. So we can actually, we need to settle these 4 intervals over here. So over here, the first one, after you settle it, you will get the y less than 0. And the second one, after you settle it, you will get the y is between 0 to 25. And the third one, after you settle this inequality, you will get 25 to 64. And finally, the last one, it will be the y greater than 64. Just like that done. This will be the answer for the question number 2D. Yes, number 2D. Okay, so moving on, we have question number 3. The boxes sold in the store. A random sample of 2,000 boxes is taken and the number of broken eggs recorded. The observed frequency are shown in the table below. Use the data to estimate the probability that an egg is broken. Give your answer correct to 4 significant figure. So what you need to do is to find the sum of the fx. So this is the x, these are the x, and this is the frequency. Okay, so just need to multiply them together. So you'll be having the 0 multiplied by 1x44 plus the 1 multiplied by 143 plus the 2 multiplied by 11 plus the 3 times 0 plus the 4 times 1 plus the 5 times 0 plus the 6 times 1. So total that you have over here is 175. So the probability is for the broken egg is 1,175 divided by the 2,000 boxes, but each box have 6 eggs. So your answer will be 7 over 480. This will be the answer for the number 1A. Now move on to the B. It is decided to carry out a goodness of fit test at 0.5% significant level to determine whether the binomial distribution fits the data. The observed frequency and the expected frequency are given in the table. So this is the O, this is the E. Then they want you to find the A or show that the A is equal to the 162.6. Over here, the A, you can just, because the total over here must be a 1. So we can just say that the A is actually equals to the total. Total is 2,000. Okay, so we minus the 1831.3 plus the 6.016 plus the 0.119 plus the 0.001, and you can see that the answer is 162.6. That is the A. Okay, so they want you to write the A in one decimal place, so the answer will be 162.6. Done. That is the answer for the number 3B. Now moving on, carry out a goodness of fit test to at the 0.5% test at a level of significance to test whether the binomial distribution is a satisfactory model for the data. So we need to build the data first, because over here you can see that these 4 of the values over here, the expected frequency is less than 5. Okay, it's less than 5. So we need to total them up. So we need to combine all these 5 columns over here. We need to combine them so that it will be more than 5. So we need to reconstruct again the table. Over here, let me reconstruct again the table. This is the X. We have a 0, 1, and greater than or equal to 2. This is the observed frequency. This is the expected frequency. So from the table just now, this one is a 1844. So this one is a 1831.3. Then A just now is a 162.6. And this one is the 143. And the last columns over here, if you total up everything over here, you get 13. And this one, you total up everything over here. So you will have 13 and 6.136. Okay, so this is the table that we need to do. So from here, we can find the critical value. Your alpha is a 0.005. Okay. Then your degree of freedom is equal to the 3 columns minus a 1 minus a 1. This minus a 1 is because of the sum of the observed frequency is equal to the sum of the expected frequency. This minus 1 is because the P is estimated. Okay, so you have 3 minus 2. So 3 minus 2, you get 1 over here. Then your critical value, it will be the chi square. With the degree of freedom is 1, and the probability is 0.995. From the formula table, you can get this as the 7.879. Okay, so with this one, now we are ready to do the hypothesis, the null hypothesis and the alternative hypothesis. The null hypothesis, you just say that the binomial distributions of the 6 and 7/480 is a good fit for the data, versus alternative hypothesis is the opposite. I mean, it's not a good fit for the data. Okay, so now we have found the critical value. Now we can straight away go for the test statistics. So the test statistics is a chi square is equal to the sum of the EI minus the OI square divided by the EI. So just 3 columns over here, 1 by 1. So over here, you can just direct press a calculator for each of the value. The first one is actually take the 1831.3 minus the 1844 square divided by the 1831.3. So over here, I will not write this anymore. I just straight away press a calculator. For this column, I will get 0.08807. And for the second column, I will get 2.3626. And for the third column, I will get 7.6784. So total up, I get 10.1. So if you compare the test statistics with the critical value, you can see that your test statistics is greater than the critical value. That means you should reject the H now. Reject H now. So conclusion, there is sufficient evidence to suggest that binomial distributions of n is a 6, the p is a 7 over 480 is not a good fit for the data. Okay, so this is the answer for the question number 3C. Moving on, we have question number 3D. Give a reason why a binomial distributions may not be suitable model for these situations. Okay, so you can, for binomial distributions, actually there are many reasons because the probability may not be constant, and they may not be independent or so on. Okay, so right here we just need to give one reason only because we just need to give a reason. So we just say that probability of success may not be constant. Okay, so we just say that the probability of success fail may not be constant. So if the P or Q may not be constant, then they won't be a binomial distribution anymore. So this is the answer, suggested answer. This is just a suggested answer for the question number 3B. 3D. Now we move on to the question number 4. Number 4, we have a researcher is interested in whether there is a difference between two school students in aptitude for English. She randomly chooses 10 students from school X and X students from of a similar age from school Y to take a written English test. The score for the student from the school X and the school Y are summarized as the following over here. You should assume that the two distributions are normal and have same population variance. So A, find a 95% confidence interval for the difference in mean score for student from the school X and the student from the school Y in English test. So over here, what you need to do is to find the bar X and the bar Y. It will be 612 divided by 10 and 444 divided by 8. So this one, you will get this as a 61.2. This one, you will get 55.5. Then we need to find the unbiased estimations of the population variance for X and the unbiased estimations of the population variance for Y. So the formula, it will be 1 over 9, 40104 minus the 612 square divided by 10. Press the calculator, then you will get this as the 294.4. Same thing go for the Y. you will have 1 over 7 of a 27460 minus a 444 square divided by 8. And you press the calculator, you will get this one as a 402.57. So we need to combine the variance together, become 1. So this will be the covariance. We call this one the covariance, SP. So SP, the formula will be the 9 multiplied by 294.4 plus the 7 multiplied by 402.57 divided by the 9 plus 7. So you will get this as the 341.725. Okay, so this is the pool variance. Now we can do the confidence interval, but before that we need to find the critical value. The critical value is t distribution because the number of the size of the sample is small, less than 30. So the degree of freedom is 16, and the significant level, the confidence level is 95. So it's a 0.975. Then you just need to use the formula booklet. You can see that this one is a 2.120. Okay, so therefore the 95% of CI for the mean is equals to the bar x minus the bar y plus minus the critical value, square root of the pool variance multiplied by 1 over 10 plus 1 over 8. Okay, then straight away press everything by the calculator. Then you can see that the smaller value is negative 12.9 and the bigger value is 24.3. So this will be the answer for the part A. Done. Okay, now we go for the part B. Use the coefficient of the confidence interval that you found in the part A to explain why there's insufficient evidence of at the 5% significant level to suggest that English score for student X and student Y are different. Okay, so this mentioned that the English score of student from X and the student from Y are different. So over here, actually, we just need to write down the mu X is the same. The English score for the school X and the English score for school Y is supposed to be the same. This is the null hypothesis versus there is a difference between the score in school X and school Y. Okay, then over here, you will get that this minus this is equal to 0. Okay, so we just say that because of the 0 is in the interval that we found in the part A, in the confidence interval, okay, for mean, which is 0 is inside negative 12.9 to 24.3. Okay, because the 0 is inside here, that means you should do not reject H now. Okay, so therefore you do not reject H now. Okay, so there is insufficient evidence at 5% significant level to suggest that the English score of students from X and students from school Y are different. Okay, so reject H now. Okay, so done. These are the explanations. 1 mark only, but I actually explained quite long. This is just for the explanation purpose. Okay, so this is the answer for the question number 4B. Then we want to move on to the number 5. Two jigsaw puzzles have the same number of pieces with identical shapes but have different pictures printed on them. One puzzle has a seaside picture and the other has a cartoon picture. A researcher believes that children will complete the cartoon puzzle more quickly. To test this belief, 10 children are randomly selected. The time taken in seconds for each children to complete each puzzle is recorded below. Carry out a Wilcoxon match pair sign rank test at 5% significant level. Test the researchers' belief. So what you need to do is we need to, usually I will review the table vertically like this. And we are using for the match pair sign rank test, I need to find the difference. So the difference over here is S minus a C. So you just minus them. S minus a C, 182 minus a 161, you get 21. And 19, negative 2, 22, negative 10, 4, 16, 27, 35, and 29. Then we will need to separate them, the rank. The P represent the rank with a positive value, and the Q is the rank with a negative value. So over here, this is the rank number 1, then followed by the 2, then 3, and then 4, 5, 6, 7, 8, 9, and then 10. So we need to find the total for the P and the total for the Q. This will be the value. Okay. So the test statistics over here, the T is equal to the minimum between these two. So between 51 and 4, the minimum value will be 4. Okay. So now we are ready to do the hypothesis test. The null hypothesis and the alternative hypothesis, we just say that the population median mx is equal to the not ms, ms equal to the mc. So S is representing the seaside picture, and this MC is the main referring as a cartoon picture, versus the population median. About the researchers' belief, the researchers believe that the children can complete the cartoon puzzle faster. So that means the median time for seaside will take a longer time to complete. Okay, so your alpha is a 0.05. Your tabular value or the critical value. This one is from the table, is 10. From the formula table. Okay, then compare the test statistics, compare with the tabular value. This is less than. That means the test statistics is actually less than the tabular value. Over here, we should reject H now. Conclusion. There is sufficient evidence to support the researchers' claim. Researchers' belief. We follow the statement stated is researchers' belief. So this is the answer for the number 5A. So now move on with the B. Show by using the pair sample size test. So pair sample size test at 5% significant level. Would the result of the opposite conclusion to that found in the part A would result in the opposite conclusion? So that means we want to use a sign test and to show that the result is opposite. So in order to do sign test, we just need to find the number of positive sign and the number of negative sign. So from the table just now, we have the negative sign, we have 2. The rest are positive. So total have 10. So the number of positive sign we have 8, the negative sign we have 2. Okay. So your null hypothesis and the alternative hypothesis is still the same like just now. The population's median, the MS equal to the MC versus the population median, MS greater than MC. Okay. So since the difference MS minus the MC will be greater than 0, I will consider the positive side. So we just have in order to do sign test, we need to use binomial distributions. The n is a 10 and the probability is always the half. So we want to count the positive sign. So it's greater or equal to 8. It will be x equal to the 8, 9, and then 10. So it will be 10C8 plus the 10C9 plus the 10C10 multiplied by the half to the power of 10. So press the calculator, then you can get this will be 0.0547. This is what we call the p-value. Compare the p-value with the alpha. Your p-value is 0.0547. This is the p-value. Your alpha is 0.05. So you can see that this is the bigger. So if the p-value bigger, that means you need to do not reject the H now. Okay. So therefore, conclusion will be opposite. Yeah. Okay. So therefore, pair sample size test at 5% significant level would result would give opposite result. To that found in part A. Okay, done. So this is the answer for the question number 5B. Moving on, we have a question number 5C. It was later discovered that the experiment had been conducted such that each child completed the seaside puzzle first, followed by the cartoon puzzle. Comment on the validity of using this experiment to test the researchers' belief. So because you have tried, the children have tried the seaside puzzle at first, then only followed by the cartoon puzzle. So maybe because of the children, they have experience already. So maybe the children, they can do quicker when they are solving the cartoon puzzle. So you just need to use your own word to give a comment on this experiment. So you just say that the children may do may do the second puzzle, may complete the second puzzle. The cartoon puzzle quicker as they have experience after they completed the seaside puzzle. So just use your own word to answer it. Just use your own word to answer it. Not necessarily follow my sentence. Any of the comment that is reasonable, that will be fine. So this will be the answer for number 5C. Moving on, we have a number 6. Random variable which takes the values of 0, 2, 4, and so on. The PGF for y is given as the following functions over here. Find the k in terms of a. So we need to know that for PGF, the G1 is equal to 1. So that means the k over the 1 minus a is equal to 1. Therefore, k is equal to 1 minus a. Done. This is the answer for the question number 6A. Move on, 6B. We want to show that the by greater than 2 is a square. Okay. So what we need to do is that we need to try to find the polynomial of the PGF. So it's a k over the 1 plus 1 minus at squared power negative 1. Okay, we make it like this. So we do the binomial expansion. Then you will get this as the 1 plus at squared plus the negative 1, negative 2, 2 factorial, and then a t square, and so on and so on. So you will get this one as the k multiplied by 1 plus at squared plus this is a 2 factorial, a squared t to the power of 4, and so on and so on. So to get the by greater than 2, that means it's the same as the 1 minus the by less than equal to 2. So it will be 1 minus the k plus the ka. So you will have 1 minus the k, 1 plus a. And just now we have found that the k is equals to the 1 minus a. Okay, so k is a 1 minus a. We just need to replace the k as 1 minus a. Then we just need to mention that from part A. So we have a 1 minus a 1 minus a squared. Therefore, you have a squared shown. That is the answer for the 6B. Move on, we have a 6C. It is given that the A is 0.2. We want to find the value of the mean, EY. Okay, so when the not when given A is a 0.2, so your PGF, it will be k over the 1 minus at squared. Just now k is a 1 minus a, and the a is a 0.2. So you will get this as the 0.8 divided by 1 minus 0.2 t squared. Okay, so over here, we actually can, for me, I prefer to use the integer form. That means I will multiply everyone by 10. Oh, no need to multiply everyone by 10. Multiply everyone by 5. Multiply everyone by 5, you get 4, 5, and then t squared. Okay, so I change it to this. Then to find the mean, I need to do the differentiations, g prime. This one, we can make it become our -1 over here. We do not need to use a product rule. Just use the chain rule will do. -4, 5 minus t squared power -2, -2t. So you will get this one as the 8t over the 5 minus t squared square. So your EY will be equal to the G prime Y of 1. So it will be 8 over the 5 minus 1 square. So it will be a half. Done. This will be the answer for the number 6C. And this will be the last question for this paper. So I'll stop the video here. I'll see you next time. Bye-bye.